Okay, delay, sorry. I had to scratch my back. So we got 40 more minutes-ish. More, maybe. Okay. Yeah, 40, and then I ended that 10 short, so 50. Okay. Trying to get 3 hours a day, because then that's like 1150-ish or 1130-ish hours in a year. And in a couple years, I mean, that should be good enough to do some stuff. Cool. Yeah, makes sense. Looks like it. Yep, we know this. We just did this. Yep. Identifiers and watched expressions value to their current values. If you want to know what it actually is valuing to. Okay. Because it's the value here, but if I want to see what it's evaluating later, then I have to go to, well, yeah, I have to go to it. Makes sense, duh. Of course. Because inspecting the value of local is common, often quickly watch the value of all local variables in scope. Debug Windows locals. Okay. Ah, that are in scope, I see. Now it's X. Now it's 3. What? Oh, because we passed it 3 and it was 5. So it was 3 at first. Check again. Oops. Oops. Okay. So it's 0 right now. Because we haven't even ran this function, so it hasn't been instantiated yet. Boom, now it's been copied to by value. Copy assign. Boom, now it has 2. Boom. And now it's out of scope. So the only thing that's in scope is Y. Local's pretty good. Many debuggers will offer... Oh, okay. It's pretty good. Call stack. I misread that. I thought it said many debuggers like people, but it's many debuggers as in software contain the option. I thought it was people use it. But. Okay. I misread it and instantly was like, "Ooh, people do it. I must do it." Call stack window. Oh yeah, because you can see. Oh, we've called a function a bunch of times. We've called one, called another, called another. Well, this one has to resolve and return a value to this one, which has to resolve and return a value to this one, which has to finish up, and boom. When your program calls a function, you already know that it bookmarks that current location because it goes, and then it returns back to where it was. How does it know where to return to? It keeps track on the call stack. Okay. All the active functions that have been called. Okay, I need something that's just like at least neutral. This is kind of weird. That's better. As well as which line of code will be returned to. Makes sense. New function is called. It's added to the top of the stack because it has to return, and then it's removed, and then it goes down. So, FIFO, first on, first off. Or sorry, it's actually FILO, first on, last off. We call main. We call print. We call add, or we call add. We call print. Print is the last on, first off. So LIFO or FILO, same shit. Middle one's the middle. It's off. First one was the first on. Therefore, it's the last off. That's main. We have to resolve all the pending ones before it can go to main. That's recursion too. Keep calling it, keep calling it, keep calling it, and then each one returns, which returns, which returns. Yep. Debug Windows call stack. Okay. Okay. Oh yeah, it's not currently showing. Debug, Windows, call stack, call stack, call stack, call stack. Boop. There it is. Oh duh, because it was on this shit or something else. That output. Now he's on call stack. We're gonna put him right in the middle, yo. No, yo. Yeah, fine. Alright. Now we want him here. Ooh, I have all these breakpoints. That's cool. Excuse me. Okay. Call stack with a simple program. So, main calls A, then calls B. So it'll say main, and then it'll say A. We should put it on, push it on the stack, and then once A is finished, it'll pop it off the stack, and then it'll go back to main, and then because it returns to main, and then main will push B onto the stack, and then it will push A onto the stack, and then A will finish up, and then B will finish up, pop them off, and then go to main. Okay. I put a breakpoint here, and then I put a breakpoint here, and then I put a breakpoint here, and we run him. Well, looky there. We're waiting on main. Oops. What? The fuck? Why didn't it? Okay. There we go. So we're waiting. We had main, but then we started the print function, and it executed it first and instantiated X, and then got to this breakpoint part and stopped. But then once this guy finishes, this is going to be popped off the stack as it was. We only have main remaining because we're still in main. And then once it's done, pop, pop. No more stackage. Program ends once the stack's done. Yep. Yep, because we were in main, so we paused on A. So we had main, but then it paused on A. So there's two things. We're waiting on A to resolve before we can pop them back off, pop them off the stack. Cool. But then once we get to B, A will be off and B will be on because main hasn't resolved yet. Okay. Top two lines. Yes. Main was called on A. Line 5 next day shows that it's at the breakpoint. Yep. 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 That's where it'll return. Okay. Ah, so it says 5. That's the current spot. Because we're always at the top of the stack. Okay. Yep. Yep. Figured that out a long time ago. Now it'll be B. Yep. Because A got popped off the stack. Excuse me. Notice that B is on the top of the stack, reflecting that B is the only function that's being, or is the function that's being currently that's actively being executed. Note that A is no longer because it was removed when it returned. Yes. To continue, it'll hit break 5 again because B calls A, and then A and B and main will be on. Yep. Now we're waiting on A to return, or rather A to finish, so that B can finish, so that main can. Yep, main called B, called A. Cool. Yeah, we can figure out the execution flow. The basics. Ooh, we get a cool part next. Oh, I just found a good spot I can put my foot in that makes this sitting still comfortable. That's nice. Stepping, breakpoints, watch, call stack window. Fuck yeah, baby. We use stepping to see what the fuck is executing. We use watches to check the values of things to see if we're making any false assumptions. We have the call stack window to see what function is actually being executed at this point. And what are we waiting on? Is there recursion going on? Is it not happening? Is it skipping through? I can't tell because whatever the breakpoint, well, the breakpoint would help you too. I think in order of importance, it probably goes stepping and or breakpoint. It's probably stepping, breakpoint, call stack, watch. No, it's actually probably this order. Like many things, becoming a good debugger takes practice and time. Trial and error. True. Okay. Yes, true. Circumstances change, the problem now comes up. The longer it sits, the more likely it will be hard to find. But it also means the harder it is to find, the longer it'll sit in the code base. Yep. Best practices. Don't program when tired or frustrated. I ain't never get frustrated, yo. Always happy. Life is just, man, such a gift. Just being able to do this. Man, that is cool, yo. I'm gonna have a wife and 10 kids someday and be able to hold them. Shit. This is good stuff right here. Okay. Common pitfalls are, yeah, study them up, yo. Make some mistakes so you can remember them. And this is understand where they are by finding them through experience. Don't let them get too long. Yes, one purpose. Excuse me, each function should do one main thing. That's why I don't like when this shit always combines stuff. It prints the sum of a value. So like I'll pass a function a value, but the function will print a sum of that plus some other value. I'd rather just call a function that returns an updated value, which is then printed. Or rather, actually better, call the print function and pass it the argument of the return value of the sum function. Standard library to writing your own code when possible? Well, yeah. Comment your code liberally. Start with simple solutions, then layer in complexity incrementally. Yep. Avoid clever, non-obvious. Yep. Readability and maintainability, not performance. Debugging is twice as hard as writing it in the first place. So if you're as clever as you can be when you write it, yeah. Yeah, so stop being fucking clever, yo. You have to dig through clever shit. Okay. Brian Kernighan. Refactoring. As you add new capabilities, you'll find that they will grow in length. Refactor meaning just breaking them back into, yep. Okay. Makes sense. A function that takes up one vertical screen. Holy. Oh, hell no. Ideally less than 10 lines. Shoo. Yeah, true. That also probably doesn't include comments. Even if I wanted to just print something. Yeah, I guess I just return it and print, yeah. But if I get input, I have to prompt the user. I mean, I could have a separate function for prompting, but that's kind of crazy. Maybe not, maybe it's not. But prompt the user, value initialize, acquire, return? That's not too bad, it's only 4. It's much less than 10. What would I even do with 10 lines of code? It's a lot. The goal here is to not minimize length. Best practices are using obscure stuff, doesn't say, yeah. There it is, had to crack my knee. When making changes, make behavioral changes or structural changes, then retest. Making both. So making it do something different and reorganizing it? Oh, hell no. Okay. Bro, what is he talking about? I was just yapping to yap like me. Defensive programming. Hmm. Catch him. A little bit at a time and test. Okay. Compiling all the time. Okay, so we're doing test add, and test add prints 200 and -2. So it'll do add 1 and 1, 2, 0, 0, -2. Test the add function by basically passing it a bunch of different values instead of having to start it every single time. It's testing different cases. A positive and a negative in each. Yeah, true. We could keep it around. All right. Unit testing. Ugh. Unit testing meaning just testing little pieces of a program to see if it's good? I guess so. Programs made of different units, you're testing them? Seems straightforward. Constraints. Oh, makes sense. We don't know conditions yet. That's next chapter. Or next, yeah. True. Excuse me. Yep. Assert and static assert. Don't know what that is yet. Oh, wait. Damn, a lot of these languages share some shit. Like Java has this kind of thing too. Primogen was talking about this. I try not to watch too much programming stuff because I want to just be interested in the stuff for me and not read all of what other people do and bore my ass. I want to figure it out, have all the fun. And he says that, let me see. It's just a better way of making certain things. And you assert something in order to check, and it just saves time. Something like that. I don't remember anymore. It was a couple days back. Static analysis tools. Linters. Basically just looks for some standard issue shit. Yeah, makes sense. Yep. Damn. Damn. Alright, sounds useful. Static analysis tool. I mean, I'll get one when one's recommended. I'm not gonna fuck with it right now. Oh shit. Cool. Oh. Okay. Same stuff? Okay. What if we did? I'm curious. Just. Okay, build. See what it says. Nothing. Cool. What if we do that? No? Okay. I guess it mainly just checks values. Another chapter, yo. Syntax errors. Yeah, that's when we're fucking up with the language itself. Basically, being an AI would help fix that. Semantic errors, faulty assumptions. Basically, the logic's not doing what we want. Yep. Debugging is fixing these with the 5-step process. Figure out the problem, understand it, determine how to fix it, and then check to see if it fucked anything else up. Finding it is usually the hardest part. Okay. Static analysis tools, check for some preset common issues. Does my calculator protect for people putting in A and other things? Maybe. I mean, this is defensive programming, so I don't know if static analysis guarantee does it, but maybe. Number of tactics, commenting things out, printing output statements, and printing values. So, I mean, it's basically the same thing. The output statements just say, hey, function executes here, function executes here. But the values are checking specific values within those functions at the time. So, I mean, they're pretty similar. It's just I'm checking the flow versus I'm checking the values. Oh, this is good, dude. This rocking feels good. Using print statements to debug. Yes, we use standard character error because it's more clear that we're doing this to debug so we can delete it later. But better avoid a log. Yeah, log records things, and when they happened, we can go check it in a text file, see what's exactly going on. Are we at 30? Nope, oh yeah, okay. Okay. Restructuring is refactoring. We're basically just breaking up things that are too complex, too long. Yep. Organized, modular, readable, etc. Unit testing, we're just testing pieces. Defensive programming, basically just QA, kind of. I mean, you're just prepping, you're trying to break a system, so make sure that it does what it's supposed to do. Assuming the misused, yeah, the program state, it's the whole state of where it's executed, what line you're on, what line you're on, what are the values of currently instantiated variables, what's going on. Debugger helps us step through individual line-wise through a function, identify values by hovering over them, by watching them another way, to just look at it, step through the function, and watch as that value changes without having to rehover. We could do expressions in there too. We can skip over functions, we can step into functions, we can step out of functions. So if I'm in one and I need to just say, fuck it, I need the return, like, give me just end the function and go on. Boom. We can do that. We can step into them to go into them, step out of them, step over them. We can skip to different parts. We can run code at cursor, run line at cursor, something like that. Run selection at cursor. And we'll start right there. But then we could set next selection or location and then skip. Integrated debuggers come with the IDE. Stepping is the name. Yep. Statement by statement, stepping into one. If there's a function there, we go deeper into it. Otherwise, it's the same thing as stepping out over. Same shit. If it contains it, it goes into the function. Yes, it's true. Ow. Stepping over, if there's a function, it steps over it and ignores. Well, it just gets the return value and it doesn't actually show us what's going on. We don't step into it to see. Stepping out, as you're in a function, it executes all the remaining shit in the function. So let's say we have a function in main. It says, that function returns an integer, and then we print the integer. If we stepped over, we would immediately just have the value, and we would be ready to print the integer if we kept on stepping over or stepping in. And if we stepped into print, we'd go into print and see what the hell, how does it print? We could see what value the print is getting, all kinds of stuff. Run to cursor basically just starts, or run to cursor. What? Run to cursor? Run to cursor, really? Oh wait, yeah. It's not run at cursor. There's set next location, set next statement, and then there's run to cursor. So we just run and stop at the cursor point, so I don't have to do a breakpoint. And the breakpoints, we just choose where we want the compiler, or rather, where we want the program to stop. At a line. Excuse me. And it'll happen every time it goes back to that line. So if we have line 43, that's in a function. We call that function a bunch. Line 43, we're going to be there multiple times, bucko. Continues it until there's a breakpoint or it completes. Terminates is the word. Start is the same thing as continue. But it starts from scratch. Set next allows you to skip. You can go back, you can go forward, you just set wherever is next. Basically a go-to, it looks like. I might just do like 15 minutes of game day tonight and then go to bed, because I think when I end at 7 hours, I get less than 7 hours of sleep, and I have been waking up right at my alarm time so I need a little more sleep. I think I'm getting more tired as the day's gone. Stamina's getting a little less. I mean, motivation's still maxed out. I don't lose it, so we're good. I just want to be even smarter. Watching it, we watch how the variable changes. We can use the watch, whatever we call it, the watch list, watch window. The watch window to see, and then we step, oh, the watch window updated, oh, we step, the watch window updated, etc. Call stack, that's the list of basically the currently executing functions. Main's always going until the program terminates. Then we call another, we push it on top of the stack until it terminates, and then we pop them off the stack, go down. You can call one, which calls another, and then they have to leave in the same order. Damn. All right. Supposed to add it, doesn't work. Why? Let's see. Oh. That'll do it. Yeah, it's not adding the 2, it's adding 0. It's because right here, this read number, we're not using the return value that it's getting, so we're saying, okay, x is 0, we read number, we put in 10, we return 10, but we don't use it, we throw it away. So this is still technically 0. 0 is 0 plus, we get another number. Let's say it's 4, so it's 0 plus 4, so x is 4 now. Or it's only the second number, it ignores the first number. And then we write answer, so it's going to say the sum is x. We pass it in, so that's why. But I'll copy it. What? Yeah. I'm not even typing right. Shit. Alright. Okay. So we step into X. Check this guy and we see that X has the garbage value. Now X is 0. We go to read number. It outputs, please read a number. It wants us to do something, so we give it 4 or 6. And we see that this value is 6. And then value is still 6, but it's a local x. We return it. But x is 0 here. Sure, 6 was returned, but we didn't use it for anything. So we have 0 for x. Because x is still 0. We're just seeing what it is here. So we're seeing it's still 0. Still 0. Still 0. Same shit. I don't even have to look at them all. I just kind of wanted to. Cool. Oh, so much more fun to actually look at the code. Okay, and then we run read number again. This time, same shit. Now we're gonna do 77. And now we have 77 here. And then we're gonna return 77 after this, once it ends. Cool, so this guy is 77. Read number, which means x will get updated to be 77 because we started with 0. So it's now 77. We're gonna now write answer and it's gonna say 77. Boom. Oh wait, sorry, not yet. Right answer. Oh wait, hold on. There we go. Yeah, we haven't done it yet. I'll do it. Cool. Now we've written it. Right answer, sum of 77. Cool. Yes, the answer is because we're not doing anything with this return value. We're not saying x equals. And then it would be x would be this plus that. So in reality, you would just do x is this plus this. Cool. Oh, 37. Shit. Oh. I'll do 13 more minutes and then, all right, no, I might as well start. So I'll be right back.